Welcome, everybody. This is Fred Schenkelberg. Welcome to today's Ascendo Reliability webinar on reliability goals. And I know I've talked about these before. I thought I'd take another shot at it since I recently, over the last couple of months, have run into a handful of more questions about it, and I've seen a handful of other variants of ways organizations talk about reliability. So I thought it'd be a good thing to bring back up again. Also, I tried to do a reboot and cleaning out all kinds of stuff to make sure my system stays active throughout this. If for whatever reason the screen goes blank, let me hang on. I'll be back as quick as I can. Welcome, Carl. And as usual, I'll have the chat window open and looking forward to what inputs and so on you have. But let's get into today's webinar. Keep my fingers crossed, it'll just keep working. Now, in all kinds of organizations, not just product development or factories or process plants or anything like that, we often have goals or targets. Sometimes we call them objectives or requirements, and sometimes we call them milestones. As far as I'm concerned, it doesn't really matter. One of the organizations I work with, they had all kinds of cool requirements. They had an engineering requirements document that listed all kinds of stuff, the duration for the warranty and all kinds of stuff. When it came to the reliability part, they called it what did they call it? I think it was objective instead of a requirement. And all the requirements had a tag on them such that they were going to track to make sure that they either met the requirement or thought through and changed the requirement. And I said, well, why is the reliability part not a requirement if that's important to your organization and to your customers? And they said, well, we don't know how to measure it. And I said, well, you know how to measure the weight of your product? Yes, we put it on a scale. And we know how to measure the color because they had to have a certain shade of blue. And it says, yeah, we have a measurement system that measures the color tones and all that good stuff. And I said, are those as important as the reliability of performance of your product? And they go, oh, no, reliability is really, really important. Okay. So why do you make it a non-measurable thing that you eventually have just don't pay attention to because you all have all of these things that you are required to pay attention to if it's important? And as you can imagine, the room was pretty quiet at that moment. And so we worked on setting proper reliability goals that are measurable. And we work through the many different ways that you can actually measure a reliability goal or objective or milestone or whatever. The problem is that if and I remember it's some quote I've heard long time ago is that if you think you can or can't, you're right. And I'm probably not getting it exactly right. If you think you can or if you think you can't, you're right. And when it comes to measuring reliability, yeah, there's some things that are maybe perceived as very, very difficult. It's really not cost effective to do an accelerated life test at everything that could possibly fail. Well, you don't have to. And so on and so on. So without getting into how to measure it, I want to focus more on setting a goal and then why that's actually rather important. So we'll get into that. So one of the questions I ask a lot when I work with an organization is, well, how do you talk about reliability? So let me ask you, how do you in an organization talk about reliability? And I forgot a glass of water up here. This is usually where I would take a sip of water. But so the chat window's open. Let me know what kind of terms or phrases or if you don't talk about reliability, maybe that's would be interesting. Um, maybe it's a measure or a metric that you're using. Always associated with something like, oh, Samir, that's an interesting one. Yeah. And as like cost or time to market or anything like that, it's always a trade-off. Is it uptime? Yep. Uptime I associate more with availability, of which, as you know, reliability is a piece of. Yeah, repairs per 100. It's kind of like a failure rate, number of cycles to failure. MTBF. Well, we got to come back and talk about that. Like it's this is an MTBF free zone, as many folks should know. Um, failures per units, all kinds of stuff. Let's see, AFR, annualized failure rate. I've used that before in other organizations. Yeah, confidence testing. As you know, we're going to come back to that. Reliability is like a requirement. It's really not testing. Testing is one way to get to it. Yeah, Maximilian, don't do that. You know better. Durability, cost associated with downtime. Yeah, there are lots and lots of ways we talk about reliability. And it's obviously important, whether it's availability for our production plant or our system or our product. One way or the other, we have ways of talking about it, and some are better than others. And I'll come back to MTBF, but try not to get too deep into that. There's other webinars for that. Yeah, Sanjeev. Yeah, you're pulling out a definition here. Under certain conditions, there's one element missing there, and anybody spot on Sanjeev's comment, he says probability of failure over time for certain conditions. What's missing in that statement? Yeah, we're going to talk about it here shortly. Time? No, he's got time there. Time or duration, as I often talk about it. Intended use. Yeah, well, it's close to that, Kenneth. Environmental conditions, use case. Yeah, certain conditions would probably cover that. Definition of failure. You're on it, Paul. It's what's the function? What's this thing supposed to do? Is it a bicycle for two that should comfortably seat two adults as they ride down the boardwalk? Or is it a, Formula One race car and that should, top speed of X amount of acceleration or whatever? What's its primary function? And we'll talk about more about that. If we don't know what it's supposed to do, it's really hard to know when it fails. Is it a relevant failure or an important failure? Those kinds of things. Part of our role in reliability engineering and working on improving the reliability performance of whatever it is we're working on really hinges on that we have a good way to talk about it and a consistent way to talk about it. And it's the first step in getting a culture that actually is likely to achieve their reliability objectives or goals or whatever. So we'll come back to this a bit. Let's see. There's 4 elements. And so the page 1 of practical reliability engineering by Connor and Kleiner. And I heard rumor that there's a new edition of that coming out. I'll be watching for that in the near future. But the page 1, they basically use a definition of reliability that I think comes from military somewhere, and it's seen in various formats and stuff like that over time. But there's 4 elements. There's always 4 elements. And you don't have to list all of the functions. And I'll talk about functions here real quick. But let's say you're doing a bicycle. Is it the first bicycle for a young child? Is it adult, quasi, somebody that's interested in racing amateur racing or semi-pro or something like that? Or is it the Tour de France caliber bicycle? What's its primary function? Is it to carry one person comfortably? Is it to carry one person as fast as they can go? You get the idea is that there's lots and lots of different bicycles out there, and there's lots of different vehicles out there and so on. But what's its very short phrase, primary function? Now, I also highly recommend is that there's probably an engineering document someplace or a marketing document that lists all of the other things that it should do, perform well. So let's say it's a bicycle. It should, weigh less than, 2 pounds. You have to pay a little extra for one of those. Let's say it has to be a certain color. It has to carry the brand logo. It has to have a certain amount of transfer of power from the pedals to the rear axle to the wheel. It has to corner at when doing 35 or 40 miles an hour over a tight turn. It has to travel on off-road, for example. Let's say it's a mountain bike. It has suspension. If you've ever worked on a product or trying to specify a piece of equipment for a factory, there's a long list: size, weight, function, performance, throughput, on and on and on and on, right? Repairability, maintainability, all of those things can be specified. And some are more important than others. We need to know what all of those are. In my experience, and maybe in yours too, is that vast majority of the time, that stuff's usually, not always, but almost always well spelled out. Now, it may or may not be coherent or in a logical fashion, yet sometimes we actually get enough details that an engineer can actually create a solution that meets all of those functions. Now, and sometimes it's competing, conflicting functions that you can have one or the other, but not both. It's really hard to create a bicycle that's less than 2 pounds, but carries 47 people with a bar in the middle of it. I actually saw one of those bicycles once in a city. It was kind of a party on wheels, and everybody was pedaling. And there was a bartender serving drinks in the middle of the bicycle. It was kind of a floating system of some sort, but it was pretty engineering wise. It was interesting. The other idea here is that those things are already documented someplace. One of the things I find missing in those documents is, well, how long should this thing last and what's the probability of they should last? Those things are missing. We'll talk about those in a moment. Reliability is a element or a function of the design of the product, and including a clear reliability statement, including the primary function in that requirements document, just makes sense to me if you're trying to create a product that meets your customers' expectations around reliability, or if it has if reliability is actually important. It should do what it's supposed to do for a certain duration and so on. Reliability statement is the reliability performance of a product is a function of that product. Yet I rarely find it in requirements documents. I'll find things like the warranty period is going to be 2 years. Okay, well, that's just a duration. It's not a probability. There's nothing there that talks about probability. Or it should have a service life of 5 years. Okay, well, how many should survive 5 years? Or it should have an AFR of less than 2% per year. Okay, how many years? Is this for 1 year or for the 2 years warranty? Oftentimes those two things are on completely different pages. Warranty is on page 97 and the AFR requirement is on page 28. If you're lucky, it'd be that far forward in the document. But the primary function is sometimes assumed if you're working on a bicycle for amateur, for home use, for recreational use, recreational rider, you may assume that, if it's clear to your entire organization. If you just hired, a Formula One mechanical engineer, they may have different ideas what's the purpose of this bicycle. Then that might be an odd hire into a bicycle environment, but they might bring some interesting solutions. The environment is the second element. It's another one of those that we often gloss over, or we say really poorly, we state that it has to meet these test conditions. Testing is not a requirement. Testing or running through a set of standards or things like that is usually involved with a subset or a sample of your products. Hence this idea of confidence that our sample represents our population, all of the bicycles, for example, and that those test conditions are relevant for the expected failure mechanisms or how our product's actually going to be used and all of those kinds of things. I've been on standards committees for all kinds of different things. And believe me, is they don't by nature represent reality. They're the lowest common denominator consensus such that you can get the thing published. If you spent 2 years on weekly meetings trying to get a standard created, you know that you just get worn out of trying to get something useful and you accept by consensus something that's less than useful. Because one of the contributors to the group is saying, well, we don't want to meet those conditions. Weather is never more than 40 degrees C. So we don't want to create a standard that says that you might see 45 C or 50 C. Well, looking at the map this summer in Europe, is they were quite close to that many, many times. And I think Delhi in India was hitting 45, 50 C at times. And so there are parts of the world where your product may actually be functional that is outside of the published standard tests or the standards that are out there. So the environmental part from reliability goal statement should be similar to a short phrase. What's the primary function and where is it used? This is a medical device used in clinics in North America or something like that. It gives us some boundaries on what it is, and then go see the environmental requirements document for this, all of the functionality elements and requirements, and go see the environmental document for where and how this product is used. Now, I did a whole webinar years ago about the environmental documents that you really should create, and some of the best ones I've ever seen. But it's not min-max, and it's not a list of tests. Those are not useful to a design team. Let's get the real data for where we're going to use it for the weather. And there's, I think it's NOAA, and I don't remember the exact website, but they have records going back 50 plus years. I find 10 or 20 years is more than adequate of weather station data. So they have temperatures, min, max, hourly temperatures, so you can get the cycle per day. You can get the barometric pressure, precipitation and amounts, wind, all kinds of things. So if you're putting together a product that's going to be used outdoors on a telephone pole, for example, in North Dakota, we'll go to the weather stations in North Dakota and get the actual weather data and then create the histograms that describe the min maxes and all of the variation that goes on with it. If seasonality is important to you or freeze thaw is important to you, you can calculate that. What is the number of freeze thaw cycles that this product is likely to see if the weather pattern is consistent with the last 10 years of data? And add some margin to it because things change and variability is a thing that 10 years won't quite capture. The idea is that the weather is just one piece of it. What we see on the weather forecast, the amount of rain, or if there's a hurricane coming or stuff like that, is just one piece of it. There's also what about all the rodents and insects and mosses and funguses and all of those other pieces that are out there? If your product is susceptible to any of those things, you need to actually have conditions documented so that the design team is heads up of these are parts of the environmental conditions that this product is going to see. Sealing for water is one thing, and it often helps minimize, in attacks by fungus or insects if it's thought through. There are some insects that like to eat through rubber gaskets for whatever particular reason that they do. There's actually a lab for fire ants testing in I think in Austin. Not that I ever want to visit there. But that's just the weather and the stresses that are around your product. If a human's going to use your product, well, how hard do they grip it? How hard do they push the buttons? Do they use their fingernail or a pencil? I've had medical products that have to be, it's a compromise or a trade-off, is that if the device itself has some electronics and some buttons on it, do we put a cover over it that will withstand the cleaning solutions that are going to be applied to it? Or do we seal and use technology of those buttons such that that surface will withstand the cleaning solutions and not allow the ingress of that liquid into the interior of the product and compromise it? In one product I used, is they were looking at field returns and there were fingernail impressions on the buttons. They used a film over the top of it, and they were regularly cutting through that film with fingernails or pens as they were pushing these things. And so somebody went and looked at, well, why are they doing that? Why are they using other objects or sharp objects to do it? And it was a combination of this sanitary requirements and cleanliness requirements and sterile environment type things, plus through the fabric or the membrane that was put over the top of it, it was very hard to get the button to actually actuate. So they had to use something more sharp to get a higher concentration of pressure on it. And so they made some fundamental changes once they understood how people use those products. Now, the idea is that same as with the environment and same with the function, is how people use it is in the reliability statement itself or goal. It can be brief. It's kind of where and how it's used. Is it 24/7 use? Is it occasional use? Is it emergency use only? What kind of use conditions has it got into it? And reference another document, usually, oftentimes, not always, but created by a marketing type effort or field service type effort of, well, how do people actually use this thing? Where is it actually located? What kind of stresses and conditions is it in? If we really count on ventilation to keep it cool and they pack it into a closet that has no ventilation, and then they pack a bunch of other equipment all around it so the vents are rendered useless, well, we need to know that as we design and build this product. And so understanding a lot about how and where your product is used is not a trivial action, and oftentimes is an ongoing effort as you learn more about your customers and new environments and new ways people are using your product. You update this document. In the reliability goal, you keep it brief and point to these other documents that have lots of details, detailed information and histograms and distributions and different kinds of use cases. Is something used in an emergency room, or is it in a clinic, or is it on in an ambulance, for example? Those all have very different sets of conditions and stresses applied. So you may have multiple sets of weather and use conditions, or stress sets and use stress sets. Nothing wrong with that. And making decisions that one product meets all of those you need that information in order to make the appropriate trade-offs and design decisions. So the function is often done by engineering and marketing and in the concept phase of your product engineering teams and so on. The environmental part is often left to the quality and reliability and to some extent the marketing folks. I often found great success in getting them involved in creating these documents because they know it's important for the product to actually work. Yet they need to be documented. They need to be written down. They need to be enough detail that the decisions made on the design or its rollout are appropriate. And the better these are done, the more informative it is for your organization. From the reliability goal part, there's a lot of detail under these. And in the goal statement itself, it can be summarized pretty quickly, but always referenced out to another document. Now, the heart of it, what most of us were talking about, whether it was in MTBF or AFR or some duration like warranty or something like that. The thing I find easiest to keep in mind is that it's always, always, always a couplet. If you say MTBF, realize that some people are going to assume that that's the duration before failure. Some are going to assume that's the duration before half of them fail. Some are going to assume that it's the duration until some number fails. But they think it's in a long way from now, especially if you have like a 20,000 hour MTBF. The issue is it's not a duration. It's the inverse of a failure rate. It's, I have a 1 in 200 or 1 in 20,000 chance per hour of failing. That basic misunderstanding is why I really don't like MTBF or MT anything. That's a story for another day. The idea of a reliability goal that is completely stated should have these 4 elements: the function, the environment, and probability with a duration. And it's always a couplet. So if I have a probability of success or probability of failure, it doesn't really matter which. Most organizations like thinking positively, despite that it is talking about failures. How many are likely to succeed, which is 1 minus the number that are going to not succeed. But the idea is that it has to be over a specific duration. If I say I want a 98% probability of success, I want 98% of our units to work, that in and of itself is pretty meaningless, because if I interpret that to mean over the next second, I might be trivial to accomplish. If that's over the next 20 years, that may be difficult to accomplish depending on your technology and product and so on. So leaving it open is not really helpful. Likewise, if I specify just a duration and say, oh, it's a 5-year product. Okay. 5 years before all of them fail, or 5 years before the first one fails, or something in between. And if I leave that up to interpretation, it will be interpreted in a range of different ways. And that's not a useful requirement or a useful goal. If you and I are working on the same product, we have a different interpretation of how many should succeed over the duration, we're working on a different problem. And we each come up with a solution, yet neither may be useful for what was intended or expected. Now, one of the things I often recommend is that you have 3 couplets. The out-of-box or early life failures, infant mortality, medical guys don't like that term, is usually a short duration. And we all know that it has usually after a product launch, those early failures, or as soon as somebody buys your product and literally gets it out of the box and turns it on and it doesn't work, those are actually pretty painful. It's unlikely they're going to buy that brand again. They're not going to tell good stories about it online, all those kinds of things. It's usually the most damaging to your brand promise. It's costs you money, it's in warranty, but it costs more than warranty most of the time. So we tend to pay attention to those, in particular in consumer products, yet in other products, it's also important. Warranty, if your product is warranted, or if you have a repair obligation for a system, whether it's under a formal warranty or not. Um, it's important that warranties are often stated as a duration. Remember, duration's not enough, right? It's not sufficient. It's not a couplet. So a 2-year warranty with a 98% probability of success is a couplet. Operating life. I worked with the HP inkjet printers earlier in my career, and they often talked about a 5-year life for the product, but they had a 1-year warranty. All right. Well, how many should operate for 5 years? And until we actually defined it and said, no, you need to have 95% survive for 5 years, that it become a real objective or a real goal, something we could measure and compare to. Just saying it should last 5 years is meaningful as opposed to saying it should last 20 years. There's different design decisions just on that separation of duration. Yet if we don't nail down the other half of that couplet, it's kind of vague, and there's lots of ways to interpret it. And that's my main point. The idea is that in a reliability goal, we can say we're going to do a recreational adult bicycle for use in off roads and on roads, like a beach cruiser kind of a bicycle. Let's say we envision a bicycle like that, a beach cruiser for recreational use by adults. It's going to work on paved and unpaved roads in North America. And see other documents for all the details. When it's first assembled, it should have a 99.9% chance of working for the first 3 months without failure. First 3 months have a 99.9% probability of success. In other words, we're saying we should really not expect too many failures at all as it's first used. Warranty, well, it's got a 1-year warranty, and because of our financial expectations and the way the part is designed and used and stuff, we expect a 1-year warranty with a 98% probability of success. The units will work for 2 years or for a year under the warranty period. And we expect the adults to use this bicycle for up to 10 years. And we expect 95% of the bicycles to survive for 10 years without failure. And that's a complete reliability statement or reliability objective. We have all 4 elements. We have plenty of other details out there, but the 3 couplets are statements that are tied to other elements of our organization and decision-making that then, depending on what part of that bicycle you're working on, if it's something to do with the assembly process, right, that might lead to out-of-box failures. If you can't assemble it correctly, it's likely not to work. Or if it's damaged during assembly or shipment. Those kinds of engineering problems are different than making sure it lasts for 10 years. The types of coatings we put on it, the type of lubrication we put on it, the type of alignment we put into the design are more likely to affect its overall operating life. And so the different couplets trigger different decisions related to different kinds of failure mechanisms. And that's the idea. If you just say it's a 10-year product with 95% reliability, the folks doing the packaging and shipping are kind of off the hook. Their problems are easy, and we don't have to worry about it because our box doesn't last for 10 years. The assembly doesn't last for 10 years. We're kind of dismissing or undervaluing the impact of failures that occur early, and so on and so on. So that's what I mean by the four elements, and that's what I mean by a complete reliability statement. Now, how do we actually create one of these things? What drives this goal? And I've given a couple of hints to that. Let me see what we got. Let's see. Kinsley's talked about confidence and reliance due to consistent good performance and integrity. Yeah, and I'm thinking of the confidence term there, not as statistical sampling confidence, but that you're uh, good with the product actually working, that you are personally accepting that you can trust that it's going to work. I'm using that kind of definition. Let me know if that's not right. Yeah, availability and reliability, I've seen that go both ways. Um, this one's not really not a talk about availability, yet the same kinds of four elements really need to apply there, plus the maintenance type activities. That how do we restore the product once it goes down, or redundancy, those kinds of things. Yeah, the probability of equipment should be available when it's intended use. Yeah, availability, and we're not going to get into it too much here, Marlek, is that reliability and the reliability goals for your system and subsystems is a significant piece of achieving the availability targets of a product. Yet it's coupled with your ability to restore a product or keep it operating, either with redundancy or with quick repairs, those kinds of things. It depends on your product. Availability gets more complicated pretty quickly. And vast majority of products and systems, and even subsystems on an availability product based product, still needs to have a reliability objective. In saying an overall goal of certain availability doesn't always give us enough details of what's the reliability of the subsystems. And there's lots of trade-offs in systems there. Let's see, Sandy mentioned over in the questions tab at B10 at some RxCX, is that reliability confidence? Define a component's subassembly for welded ones, non-removing parts. Yeah, B10 is a market, is a piece of it. Yet if I'm making a bicycle and I want 98% reliability over some duration, B10 is the 10th percentile of failures. It's kind of far away from what I'm actually interested in. So how does that curve manifest out to the tail? What's doing this thing? All right, getting a couple of notes here. Samir is mentioning business goals drives reliability goals. Well, does it really? Let's talk about that. All right. Part of it is through technology. What's possible, right? If I'm going to use titanium for this, I could probably make a really light bicycle. Oh, wait a second. What if I use carbon fiber instead? Or if I use some other Heizoots weird material that's super light and super strong and all these other things. What's possible in the technology? Now, if it's not possible to make a bicycle that will work on the beach and in a race and on a mountain, a trail in the woods or wherever, and always be comfortable and never slide out. It's impossible for that bike to um, slide out and drop or push you over the top of the handlebars, or all the different ways we can fall off of a bicycle. It's just not I don't know that we have the technology to make a bicycle that won't cause you to fall. I wish I had one of those when I was first learning to ride a bicycle. That would have been nice. And seeing one of the comments here is driven by the customer. In part, customers may want something that we can't technology-wise create. So there's a couple bits and pieces here and trade-offs. And what we really hope for is that we find intersections of a couple different factors that allows us to pick a spot, part technology, part what's possible, but also part, can we actually create it at a cost that customers will buy it? This is part of that customer input, right? It's not the only one, is that will they buy it, and encourage others to buy it so that we sell more than one, and we still have a profit margin. So if I use the greatest materials in the world and it costs me $1,000 to make this bicycle, the customers will only pay $200 for it. We're not going to make any money on that. It's kind of the opposite direction. But if we can make it for $200, that meets their expectations, which is the third criteria, and we can sell it for 1,000, well, then we got a margin, we got a business. Now it's cost and purchase price and all of those factors are part of that business element of it. What can we make that will work in the market? And part of that's understanding the market, the competition, the ability, the technology that we have available. How do we going to engineer and meet these requirements in performance factors and so on? Yet technology and cost are just two of them. The third one is the expectations, the customers. What do they expect? What is our brand promise? Are we always the leading edge, using the greatest materials? Yes, it costs more, yet you get great performance out of it. Or is it a rock steady, don't take any risks? We know we have proven technologies and we have a modest price, yet the product just works. It just works for a long time. What is our brand promise? What is our perception in the market of what we produce? And changing that, going to a less reliable product, may undo part of that brand promise you have. And as you all know, that's important in your business. The brand acceptance or promise is a part of the buying decision, and even them just looking to you to buy your product. The other side of it is, the really hard part of this is that the expectations change. We want lighter, faster, easier to maintain bicycles. I'm thinking of phones. I don't know how many of us are expecting cinematic quality phones on, or cameras on our cell phones, yet they're becoming available. It's amazing to me. It's like, okay, I guess YouTube is driving the market on that one, or whatever our video making aspirations are. I just like a phone that actually makes a clear phone call, that when I'm up in the mountains, I can actually, check in and make a reservation for dinner when I get off the mountain. I haven't found one of those that works yet. Well, I guess I don't have a satellite phone, so I should probably find one of those. The idea is that it's a complex thing that goes into how the goals are set. One of the funny things is that it only takes a few minutes to actually set a goal. A lot of the expectations have been thought through and worked out, or hallucinated in some cases. The technology, the early concept of a product, we're going to make this out of titanium, now we're going to make it out of steel, it's going to be heavy, but that's the robustness of this product for a child's bike. We're going to do, I remember banana seats on my bicycle, my old Huffy. Thing weighed a ton, but it had a seat that you could actually put your buddy on the back of the seat and ride down to the store, for example. What's the expectations is one part of it. What's the cost? My parents weren't going to buy me a race bike when I was 10. It had to be cheap down at the local store and available at the local store. And so it had to be relatively inexpensive for inventory and storage and manufacture and all those things. And it had to be, robust. Who knows where I was going to ride that bike? You find that all three of those tend to be, looked through and thought through by different parts of your organization. We'll put them all in the same room for about 10 minutes and say, we need to establish a reliability goal. If we use this material that degrades with sunlight and it's a bicycle, how long before that degradation will make this bike unrideable? Well, there's a technical limit to how reliable this bike can be. It's better to set those trade-offs off right off the bat and talking about the impact on its reliability performance from all three of those factors of these different considerations will help you set a goal, usually very, very quickly. Now you can do more analysis, you can do market analysis and segmentation and all these other have really cool stuff if you've got the data and if it's important to you. But at the end of the day, you need those four elements. What's the reliability? What's the function? What's the environment? What's the and the couplets, the three couplets of probabilities and durations. Getting that set and setting it up as a requirement or whatever you want to call it, such that it's very clear to the organization that that's what we're making, and this is its performance criteria, is a blend of all of these different elements and probably more that allows you to quickly set or establish a reliability objective. All too often, I've heard people say, well, they're asking me, the reliability engineer, to set a target. Well, set one. You probably are aware of all of these considerations or factors. If you're not, go talk to the people that have this insights and background and information for you so that you can set a rational, meaningful, and something that can be used as a reliability requirement. Yeah, in some organizations, Sanjeev, I do agree that reliability objectives are driven by a customer. They'll say, I want you to make this product for me and it has to do this, X, Y, Z. And that's a requirement. Well, part of that discussion of, well, how heavy is it or how tall is it? I'm thinking of Halt chambers. I don't know how many different labs I've seen where they've had to cut the door open and to accommodate the size and height of a Halt chamber coming into the lab. For whatever reason, the Halt chamber manufacturers don't respect door sizes on typical labs, and they expect you to remodel your lab doorway so that you can get this thing in and out of your building. I don't know if that's still the thing yet. I don't think our buildings have gotten bigger doors just to accommodate Halt chambers. So it's part of the process here, folks, is you got to understand your market and the constraints and activities and additional costs that you're asking them to incur. The idea, though, of customers saying, I want this, and they ask for, I want it to be reliable, or I want a certain MTBF, or I want it to last this long, really has to include, well, over what duration, or in what environment, or what's the, we have all these other functional things. What's the primary function? Let's detail a full reliability requirement from our customers, because they rarely will come to you with all four elements, probably three, and you still need the other one. All right, one last thought here. I wrap this one up, and I have talked about the value of what we do a lot of times, but have you ever thought about just the goal, not achieving the goal? There's value in achieving a goal. There's no doubt about that. What's the value of just having a goal? You're just establishing a clear 4-part goal with 3 couplets. Why is that useful? How does that actually save you money or time or conflict or trade-offs or whatever? How does it actually useful? Give you a vision, you know where you're going. Yeah, it's part of that. Right on, Carl. Clear expectations. Yeah, it's just like saying it has to be less than 2 pounds. saying it should last for 5 years with a 98% reliability in this environment, in this use cases, and with this functionality, it makes it pretty clear what we're trying to achieve. And you can all see how that will change. Well, what materials do I pick? What trade-offs do I do? What kind of attachment methods do I use? What kind of added bells and whistles or features should I put into it? Prevent rework, keeps you focused, clear expectations, all good, all good. I don't think I'll have to go through this too much. The basic idea here is alignment. If we know that we're making a bicycle and we want it to last 2 years in race conditions and weigh less than 2 pounds, although probably even lighter these days, it gives us a pretty clear picture of what we're trying to achieve. Now, there may not be that many possible solutions for that. Engineers are clever, there's no doubt about it. Yet, if we're not all working for a product that's going to last 2 years with race conditions, then the likelihood of us achieving that is pretty low, or we'll discover these conflicts and these inappropriate or wrong-minded or wrong-based or wrong assumptions that led to poor decisions late in the program, and that'll cost us money. So if we have a good idea of what we're trying to do, it can guide the sets of assumptions that we make when we make decisions. And we can avoid later stages, issues and problems and failures in our design process that lead to rework or to redesign, or that don't quite meet all of the goals that we have for the product going out. Now, many of you have been to previous webinars, and you may have heard the story of I was talking about, so how do you talk about reliability to an engineering team? Now, it turned out all 3 people were working on the same product, same circuit board. And it wasn't a big circuit board. It was relatively modest size. And there was electrical engineers. That one was more the digital side of things. The other was the analog side of stuff. But they really did have to work together to make this all work. And their manager. And they all said they had a MTBF, which had issues in and of itself of X amount. And they all knew what it was. And which was good. Not all organizations can say that. And I said, so what does that mean to you? And the first one was, well, I have to gold plate everything. It's really difficult to achieve that goal. I have to buy the best components. I have to set up a lot of testing. I got to make sure that I have lots of margin. It was going to be difficult to do it. I thought, okay, knowing a little bit about electrical engineering and not really about their technology, I was okay, that's interesting. Thanks for answering the question. And the next person had the exact same goal, same product, same circuit board they were working on. And I asked, so what does that mean to you? And he says, well, I pretty much ignore it because it's going to be so easy to achieve that goal. I'm not really worried about it. I use the cheapest parts, the cheapest vendors. I do, trade off that stuff. I don't need any margin. This is going to be a piece of cake. And I said, wait a sec, aren't you working on the same board as Sarah over there? And oh yeah, we work on the same board. Why? She doesn't think this is easy? And they hadn't talked about the reliability objective at all. And so they were putting vastly different levels of quality of components and thought into the design on the exact same board. And I'm like, okay, well, it may or may not be appropriate. I don't know. Maybe they have different roles in the design of this product. And the third person's the manager. She knew the exact same goal. And I asked her what it was for. And she goes, oh, I ignore it because we don't measure it. Which brings up the idea that just having a goal often does bring this clarity or vision or everything else. Yet, if I'm making that two-pound bicycle, every prototype, every simulation I do, I can estimate the weight every day. There's somebody that's calculating the cost of all of the final components that are going into this and saying, are we meeting our cost objectives? We tend not to do that with reliability every day. So setting a goal allows us to have a benchmark or a marker to compare the measurements to. Now, I'm not talking about measurements and setting a goal, and it's not the sole purpose of the value of a goal is being able to compare it to the measurements. Yet, I'm going to caution is that if you don't measure it, that alignment's going to fade real quick. So part of that alignment is having a starting point and here's what we're trying to achieve. Here's the light at the end of the tunnel. Maybe that's not a good analogy. The idea is that we need markers or milestones or measurements along the way to make sure that we're on target, right? Or do we need to change that requirement, that goal, in order to meet the technology limits or the functional limits of our product and those kinds of things? It's part of setting the stage of how we talk about reliability. And the alignment with the goal itself is a start, yet it needs additional activity, whether modeling and estimates and measurements and testing, or physics of failure, or whatever the techniques we have. But we need to compare something to the goal. A goal standing by itself is not useful in and of itself. It has some inherent value, yet that will fade unless we actually start measuring it. Which brings up that your goal really needs to be measurable. And this is what I'm talking about. I think I got ahead of myself a little bit. The idea is to get feedback to the team. If our first design and our first mock-up and simulation says this first design is 3.5 pounds of metal and materials on this bicycle, and our goal is 2 pounds. Can we achieve our overall business objectives and meet our customers' expectations if we manufacture a 3.5 pound bicycle? And we can make that decision to change the requirement. And if not, if 2 pounds is really, really important to our customers and to our business success for this product line, well, then we need to change the design. Now, the exact same logic goes with the reliability part of it. If we really want 98% reliable over 2 years in our full statement, and our current estimate is that we're at 90%, well, we need to do something about that. We either change the requirement, which is always possible, or we change the design in order to meet it. Now, the third thing that comes into mind is that sometimes, like we put up a system model, we may not have good estimates for some parts of our design. So we leave that as vague at the moment and really a relatively low estimate until we can get better data. Let's go do that accelerated life test. Let's go get better information. Let's take a closer look at our field data. Can we suss out what's a reasonable estimate for this? Sometimes we need better information, and it improves our estimate of the measurement of the reliability, and we compare to the goal. But sometimes it's just a trade-off, and we're going to have to change the goal. Yet we need the measurement to do it, and we need a goal statement that is measurable. If our product goal is 5 years, that's it. How do we measure that to know if we're on target? Vice versa, if we have an AFR of some value, 200 or whatever, over what duration? So how do we measure that? Annualized failure rate is a clean way to do that, yet over how many years? Is it always the same, or is it increase or decrease as we go from month to month to month? So making a complete statement really does become important again. And the last one is priorities. The value of the goal is, especially connected with a system model and estimates of the various elements of our system, but even before you even have your first estimates, an FMEA, having a goal and what could prevent us from achieving that goal, that requirement, will bring up that Pareto of these are likely failure mechanisms that will ruin our day. And we need to to understand better or focus on those. And Chris Jackson likes to talk about it as the vital few, and I think Carl also does this, is we don't need to make everything super reliable. We need to make the ones that would limit the life of the product good enough. So part of the focus of a team is the focus on the things that are important, the vital few, the things that will limit the life of the product or we don't know enough about and we need to understand better. So let's focus on those things and do the, as Chris likes to say, the free, cheap, and easy, the free and easy things early in our design process to get those vital few taken care of, and then move on to the more niggly ones that are more difficult to sort out as we refine the design and get better information. The idea is that unlike one team I ran into, is they had a reliability goal of 98% over 2 years, for example, is a fraction of their overall statement. And they interpreted that as that every component had to be at 98%. And if you follow the logic of that, is that they, end of the day, the 5 elements they had, 0.98 times 0.98 times 0.98, they were able to achieve all of the 5 subsystems in the component at 98% reliable over the duration. And thus they were nowhere near their system goal. So having a system goal and then breaking it down to the critical components or the critical subsystem of your product and having sub goals that then mathematically still will help you achieve the overall goal really does help you set priorities, what's achievable, what's easy to do, and so on. Let's focus on the things that make a difference. And it's the same in mechanical engineer, electrical engineer. We focus on the things that will make or break our product's performance. Well, same with reliability. All right, so handful of things there for you to think about. And this is a rhetorical question for you. And if you'd like to stay on the line and talk about it, I'd be happy to entertain questions and comments and stuff on it. Do you have complete goals, and are they working for you? Are they actually helping you in your organization create a reliable system? So with that, I'll stay on the line and see if there's any more comments or questions.